Welcome to the JR Pack Testing training video. Within this 40-minute demonstration, our engineer will teach you the basics of pack testing. Martin will carefully show you how to complete each different type of test to the correct standard, safely and carefully. Hannah and Joanne will then offer you guidance on working with our clients and the standards expected of you. Please sit back, take notes and always feel free to reach out to us with any questions.
So now we're going to be looking at testing a computer monitor and the computer base station. So first of all, we're going to start off with the monitor, and we're going to be testing the IEC lead first of all. And as the lead is actually classed as an appliance in its own right, so we will test that separately, and the reason for that is that lead could effectively be used on any other similar type of appliance, i.e. it could be plugged into the computer for its power source, it could even be plugged into a kettle, hence the reason sometimes they're called kettle leads. So we're going to plug the IEC lead into the machine. Thankfully this cable is long enough to reach round. Put the plug into the pack testing machine, and we're just going to conduct a Class 1 appliance test. My machine is actually pre-programmed to do IEC tests, so I'm just going to select the appropriate test on the machine when it works, and then it's going to go through the process. So it's now going through the test, testing the IEC lead for its earth continuity, its insulation and its polarity. And thankfully on this occasion this lead is all good and safe to go. So what we're then going to do, we're going to record that IEC lead details onto the machine, and we're going to label it up accordingly as a pass. So that's all recorded, ready to go through. Going to leave the plug actually attached into the pack tester machine, reattach the IEC lead to the monitor, and then we're going to conduct a Class 1 test on the monitor itself. So using the probe to find some exposed metal parts, we're then going to conduct a Class 1 test to test the earth continuity of the monitor. That's showing a very good result of 0.01, and then it'll continue through to the insulation test. That's all passed. So again, use a label. We would take off the old labels first, put a new label on to show that it's passed, mark up the results on the machine, and then we will move on to the computer base. What we need to remember is, after conducting the test, is to conduct a functionality test just to make sure that the monitor is working. As we go to computer base, I will check both of those at the conclusion of both tests. So onto the computer base. Again, we've got an IEC lead that goes into the back of the base station, so we need to test that first, making sure that the fuse in the plug is the correct ampage for that device, which I can see that it is. And again, we're going to do a Class 1 IEC test. So the machine will do its magic, and I can see the earth reading is good. The insulation is good, and now just waiting on the polarity, and again that's good. So again, we'd remove any old labels, we make sure that that's nice and clean for the label to actually stick to put it on, and we'll record the details of that test on the machine. We'll then remove the IEC part of the lead, put that back into the base station, and this time, because we are dealing with computer equipment, we need to reduce the voltage that we are using. Normally on the pack testing machines that goes through at 500 volts, but because we're talking about IT equipment, that amount of voltage could cause some damage to the internal components, so we need to reduce that down to 250 volts, and we do that by doing a 250 volt test. So again, this particular device has got a number of pre-programmed tests, and one of them is a Class 1 IT equipment. So I'm going to select that on here, and then we're just going to run through the test. So again, finding some exposed metal parts on the computer base station, we will then run through the test. And that's much safer because it's just going through at 250 volts rather than the standard 500. And this is where I need to then plug in to test the PE current. And that test is complete. So now we're going to be looking at a typical kettle and kettle base. These need to be treated as two separate appliances. We're going to again do those visual inspections, check the fuse ratings against the plug, and I've already done that already and I'm quite happy with that. So the kettle base, both appliances are class 1 items. In order to get on this type of kettle base an earth contact, you'll just see this little copper prong that comes out of the base. If there's not one on the side, there's usually one underneath where you can shove a prong in. So then we're going to select a class 1 test, and then all we're going to do with the probe is just push that copper prong in order to get that exposed metal contact, and then we're going to test the lead and the base. So again, the earth reading test, then I'm going to do the insulation test, and that's all perfectly fine. So we'd record all the details of that on the device, put a label onto it, and that's passed. We then obviously need to test the kettle itself. So what we do then is keep it plugged in, and all we're going to do then is test the kettle. Because I can see there's an element going down the side, it's a little bit easier to get. Some kettles like this just have the flat base, and if that was the case you just push the prong down onto the metal base, but I'm just going to use here. One thing you need to be sort of a little bit conscious of with kettles is the build-up of lime scale. You also need to make sure that the interior of the kettle is dry, otherwise that will affect your earth readings. But lime scale will also affect, this is a relatively clean kettle, but if you get a failure with a kettle, what I would suggest is just check the lime scale. If it has got quite a bit of lime scale, just get a screwdriver or the end of your crocodile clip or your prong just to scrape that down to expose the metal better to get a result. But again, all it is a class 1 appliance test, so we're just going to go through to test the earth. And that's fine, and then all it'll do then is continue with the insulation test. And again, that's coming up fine. So yeah, again, we'll record the details onto the machine or onto your laptop or paper, whichever method you prefer to use. We'll attach a label onto to say that it's passed, and that's it, complete. So now we're going to look at testing a typical toaster. So again, we're going to do a visual inspection, make sure that we're happy with the device, and toasters are a class 1 appliance. So checking the cable, again making sure that nothing exposed, everything's in order, which it is, and then we're going to check the fuse. I know from experience that toasters are a typical 13 amp fuse, and this is a 13 amp plug, so just going to quickly open the plug. First of all, just to make sure that it is correctly wired inside, no kinks, etc. And actually that is actually a good example of how a plug should be wired. Quite pleased with that really, and I can see that it is a 13 amp fuse. If that is untidy, we should be correcting that to make sure that it is in order once we've had a look at it. So we're going to put the plug back together, make sure it's nicely tightened up before then going to conduct the test. So I'm going to plug the appliance into the device. And instead of using a probe on this occasion, I'm actually going to use a crocodile clip, but the probe will work perfectly fine. Again, just my experience is it tends to work better with the clip. And then we're going to get it onto the elements. And it's a class 1 test, so I'm going to select class 1 appliance test and let the machine do its thing. Showing 0.08 on the earth. and well over 20 on the insulation test, which shows that the appliance is working perfectly fine. We will record the results. On this occasion I would see about removing the label from the plug, the old labels, and then depending on the client's needs, whether they want labels present or visible, I would either put it back on the plug or put it somewhere else if they wish them to be hidden out of sight. Right, so we've got a couple of appliances here, and first of all we're going to look at this portable lamp. Now this is a class 2 item, which is identifiable by the double square, a square within a square. And also one of the other giveaways is that the plug, the top part, which is normally the earth plug, is made of plastic, so it tells me that there's no earth. So a very simple class 2 test. Plug into the machine, select the correct test, attach the probe to part of the metalwork, exposed metal, and then we'll just go through an insulation resistance test, and that's showing it's perfectly fine. So as with every test, we've already conducted the visual inspection, we fill in the details, we record that, and we attach a label onto a nice clean part of the appliance. Okay, so now we're going to look at what is a typical class 2 appliance, a fan. Some are class 1, but this one is a class 2, and I can identify that by the square within a square on the appliance label. So very quickly we're just going to plug the appliance into the pat testing machine, having completed all our visual inspections, and we're going to attach the probe to a metal part of the appliance, and we've got a bolt just here on the side. So we're going to do that to complete the circuit. Select a class 2 appliance test, and it'll go through the insulation resistance test. That's showing perfectly fine. That's quite simply the class 2 test complete. We then annotate all the details onto the device, or whichever method you use, and the test is complete once we've applied a label on a clean, clear, visible place for the appliance. Right, so we're looking at one of these commercial fridges now, which have some of their own difficulties in terms of getting access to wherever the plug is. So as you can see with this one, surrounded by other products, I can see that the plug's down the back here, so I'm going to make sure that I've got plenty of space to work around, being careful not to ruin the shop's display. And we're going to conduct a visual inspection first of all, so I'm just going to walk around the appliance, make sure that there's nothing giving me any sort of concern. You can see the old labels there. Yeah, nothing giving me any concern. So then it's trying to get access to the plug, so I can see it's down here. So I'm going to quickly, whilst it's still there, just quickly have a look at the cable whilst it's still in situ. No kinks, no tears or anything. And I'm going to quickly make sure that the socket is okay, making sure that it's not loose. If it is loose, then if we can, we will just quickly tighten it up. If that doesn't work, then we need to make sure that we report that to the responsible person so that they can get those repairs undertaken as quick as possible. So I'm going to take the plug out, put it into the pat testing machine once the machine switched itself back on, and effectively what we're going to do is a class 1 test. So I'm going to select the correct test on the machine, and then we're going to find some exposed metal parts. What I'm going to do is use a screw stud just down here, and then we're going to go through the test. And that's showing a good earth reading of 0.01 and an insulation of over 20. So that test is complete. So what we're going to do is we're going to record all the details into the machine or onto the iPad or onto paper, whichever one you use. We're going to apply the label in the most appropriate place, and most importantly with this type of device, this type of appliance, make sure not only do you plug it back in, awkward space, but we'll get there. And that it's switched on. But the functionality test of making sure that it is still working. Well, very important, certainly with fridges, freezers, etc., to make sure that they are back working, because what we don't want is the food going off and the products then being no of use and us subsequently getting a compensation claim being made against us. And then make sure that we leave the area exactly as we found it. So we've already conducted a class 1 test appliance on this microwave and it has passed. However, we now need to conduct a microwave emissions test. In order to do that, we need to put a glass or a cup of water inside of the microwave, and this test needs to be conducted while the microwave is running. So we close the door and we set the microwave going. Let that just go for a couple of minutes or for a few moments. We're going to switch on our device and we're going to 0 it, and then we're going to press the max button because that will record then the ICE reading. So then we'll start to conduct the test by running the device around the machine, around the microwave. There'll be some emissions whilst it takes its different readings. Go all the way around. And that's actually indicating that this is a failed item. It's indicating that it's well over the acceptable limits. So this, although it passed its class 1 appliance test, the appliance itself is failed because of the microwave emissions. So that is clearly a failure. So what we're going to do is we're going to mark it up with a red failed label on the plug, and I've also put another red label, failed label, on the top of the appliance, so it's very clearly marked. This microwave now needs to be taken out of service as it's technically dangerous, and we will inform the responsible person of the fact that we have taken this out of commission and they are to dispose of it. So now we're going to look at a typical commercial kitchen with the various appliances that we have inside a commercial kitchen area. And first of all, we're going to examine the traditional fly zapper, which is a class 1 appliance. So the first thing we're going to do is do a visual inspection, make sure that we're happy with everything. And we're going to look at the cable, make sure that none of the cables are exposed, no tears or cuts in the sheath. And then we're going to check the fuse rating for the appliance. I can see that this is a 23 watt appliance and the plug is showing that it should have a 5 amp fuse, so I'm happy with that. So it's just a quick check, with it being a molded plug, of checking the fuse. And I can see that that is a 5 amp fuse, so I'm happy with that. So we're going to plug the appliance into the pat testing machine and we're going to select a class 1 test. Then, using the probe on this particular occasion, we're going to find some exposed metal parts to conduct the test, and then we're going to commence the test. Going to make a note on here of the environment, the plug, the flex, the socket, etc. I'm happy with all of those, so I'm passing all. And then we'll go into the first part, which is the earth continuity test, and then it's straight into the insulation test, and both are showing a pass. So I'd record all the details into the pat testing machine, or depending on which device you use, whether you write that down on paper or whether you record it onto a laptop to send to the office. We will then fill the label, would apply that to the appliance, ensuring that we've removed any old labels from the appliance, and that appliance has passed. So once we've concluded all the tests, we've made a note of his results, we need to finish the test by actually conducting a functionality test, which basically means just making sure the appliance works. So I'm going to take this over here where there's an available socket, and I'm just going to plug it in, and then we're going to switch it on just to make sure that the appliance is working. We can see that it is, so the functionality test is complete, and that is everything completed with that appliance. So now we're going to be looking at a typical till area in a shop. One of the problems that we have with areas like this is that unless the client wants us to do so, we would need to switch everything down. So because that causes issues for the clients mainly, we only conduct visual inspections on till equipment, card reading machines, etc. So all I'm going to do is, we've got a series of tills here, just going to check all around these, just doing visual inspections, making sure that there's nothing of any concern, no exposed cables, etc. I'm going to do that for each of the tills. And then what we're going to do is just check under the till areas and make sure, again, visual inspection on all the leads and everything, exposed cables and what have you that we can see underneath the till area, but it is just visual inspections only. So what we would do is, as we check each of the appliances, we would record those on either on the appliance, on your sheet or on your iPad, to make a note of them so that they are all recorded, given an asset number and all labelled up accordingly. But most important, unless the client allows us to do so, these would only be a visual inspection. So now we're going to be looking at testing this coffee machine. Now, it's a rather large appliance, and on this particular occasion it doesn't have a plug, which means testing it is somewhat a little bit different. It's still treated as a class 1 test, but we're going to treat it as a fixed appliance. Now, normal procedure for a fixed appliance test would be to isolate the appliance at the main consumer unit, and we would go through a lockout procedure with the consumer unit. However, looking at the cable in here, I can't ascertain where the consumer unit is, so we're going to do a basic earth continuity test using the spur switch. So what we're going to do is, I'm going to select a class 1 appliance test, fixed appliance test, and I'm going to conduct the visual inspection. So again, just looking around, making sure that everything appears okay, checking the sheath on the cable and making sure that's all in order. So I'm happy with the visual inspection. So I'm going to select a fixed appliance test, and I'm going to attach a crocodile clip to exposed metal parts, and then using the other probe, I'm going to attach that to the screw on the spurred switch in order to conduct an earth continuity test. The machine is making sure that I'm away from the device, conducting the test. Now, on that particular occasion, it's showing a fail. Now, it's not a fail, it's probably because I've not found the right metal part to conduct the test with. So don't automatically record it as a fail, look for another metal part to actually conduct the test with. And sometimes it is quite a bit of trial and error. So I can see there's an heating element underneath the machine. There we go. And then I'm just going to redo the test again. And although it is actually giving a reading, it is actually showing a fail. But I'm going to conduct the test yet again to satisfy my own mind. So again, I'm going to put the probe on the screw of the spur, and we're going to restart the test.
Not this one. No, this one.
0.18, just have to work out on that. Yeah, it's a pass that, isn't it? So although the reading is coming up on my machine because it's pre-programmed, the result is actually within the acceptable range. Right, so now we're going to be looking at testing a class 1 fixed appliance such as this cooker, and we're going to be doing it as per the correct method in the 5th edition. So the first thing that we need to do before doing anything is making sure that we have got the appliance isolated at the consumer unit. So we're just going to quickly go and sort out the consumer unit and lock the fuse off. We come to the consumer unit, and as you can see, I've isolated the power at the main switch and also on the cooker circuit, and I've already attached a piece of lockout kit that prevents that circuit from being re-engaged and coming live. And to ensure that nobody then can take it off, we then attach a padlock onto it, secure it, so that we know we are completely safe. Right, so now we've got the consumer unit isolated and locked off, we're now going to see about removing the screws from the socket. Okay, so now we've opened up the socket, we need to just make doubly sure that it is no longer live. So just using a quick electrical tester, we're going to just test against the earth, the neutral and the live cables, just to make sure that we're satisfied that there's no current going through. So the next thing we need to do is to disconnect the live and the neutral from the socket. Right, so now that we've exposed the socket, we're going to get on with actually conducting the test. The first part is the earth continuity test. So in order to do this, we're going to take one probe with the crocodile clip and attach it to an exposed metal part, and I find the grill element on an oven works really well. And then with the other part of the probe, with the live and neutral cables separated, what we're going to do is use the probe on the earth point and conduct the first part of the test. Conduct all the visual inspections. It's actually going to ask me to make sure that everybody is safe from the supply, and I'll continue with the rest of the test. So that is the first part of the test done. We've given a good earth reading. So the next part is to conduct the insulation resistance test. So we take the crocodile clip that we'd use to connect to a metal part of the cooker, and we link the live and neutral connections, and again we use the probe on the earth part of the socket to conduct the insulation resistance test. Again, it asks me to make sure that everybody's safe from the system. Conduct the test to give its result, and again that's showing a good resistance level. So as with any other test, we fill in the details on whichever method you use, whether that's on the device itself, tablet or paper, and we would put a sticker on accordingly to show that it's passed. We then disconnect all our clips, and then we need to see about reassembling the socket. So what I'm going to do now is just reconnect the live and neutral cables, and then all we're going to do is put the socket back into its fixtures and fittings. Right, so now that we've all put it all back together and we have at the consumer unit we've made all the switches back live again, we need just to very quickly conduct a functionality check of the appliance. So switch the cooker on at the wall, and all we're going to do, can see that there's electricity coming through, and we're just going to make sure that the oven part is working, and which it is, and so we can switch it back off again. And that is then the test for that class 1 fixed appliance complete. So now we're going to be looking at testing a 110 volt transformer. Sometimes these can be a little bit difficult to get an earth reading from. So I'm just going to show a little tip that I've picked up on how to do this. So first of all, again, as with any piece of equipment, we're going to be doing a visual inspection of the appliance. Mainly just checking the cord to make sure there's no cuts or etc, any coppers exposed. And we're going to be checking the correct fuse rating for the appliance. And then what we're going to do is we're going to plug the appliance into the pat testing machine, and then I'm going to select the 110 portable class 1 test. Now what I found is use the probe rather than a crocodile clip, and using the earth part of the connector, you'll notice that one is slightly wider than the other two, and that is your earth probe. So all I do is get the probe, and you can just see inside there is a copper sheath, and all I do is I slide the probe down until it makes contact with that copper probe, and just hold it there whilst doing the actual test. So then sledge along and let it go and do its thing. And that's showing a really good earth reading of 0.01, doing the insulation resistance, and then it'll do a sub-leakage test. And that is the transformer complete. So that knacky on that one is just to slide the probe along the inside until you can feel the copper sheath inside for the earth. Again, we then record the results onto the machine or onto your laptop or your iPad or paper if you still use that, and then we would mark that up accordingly and attach a new fresh label. So then we're going to move on to another appliance that we've got here, which is a 110 class 2 power tool. Again, I know it's class 2 because I've checked to make sure that we've got the square within a square. So on this occasion we need to use an adapter to plug into the pat testing machine. So that connects quite simply and secure. Plug into the pat testing machine, select the appropriate test on our machine, so class 2, and then we go through the test, but we just need to find something metal which is just inside here with the probe just to complete the circuit, and then we go through the insulation resistance test. Again, that's shown perfectly fine. Then it's doing a leakage touch current test. That's showing perfectly fine as well, and that's the test complete. Again, we just fill in the machine for those results, attach a label on the nice clean part of the appliance, and that's the test complete. Okay, so now we're going to look at testing a typical 4-gang extension lead. So probably about a 2 meter length of cable roughly. So what we're going to do first of all is do a visual inspection, make sure that there's nothing giving us anything concern, quick check along the cable, make sure there's no cuts, tears in the sheath, certainly no exposed metal cabling coming through, so I'm happy with that. So then I'm going to check the plug. This is a moulded plug, so a quick look on the plug, and I can see that it's got a 13 amp fuse recommendation for the extension lead. So we'll just expose the fuse just to make sure that it is actually in fact a 13 amp fuse inside it, and it is. So then to conduct the test we're going to use an IEC lead, so we're going to plug the extension lead into the pat tester, and then using an IEC lead we're going to test the extension lead. So this particular pat tester has already got a pre-programmed test for an extension lead, and all I have to do is choose the program with the correct lead length. So on this occasion it's up to a 6 meter lead, and then it's effectively a class 1 appliance that it will go through, ticking all the boxes to say everything's in order, we'll conduct the IEC lead test, the earth continuity, the insulation, and then finally it'll conduct a polarity test. And they've all passed. It will then record the results onto the machine. However, what you need to do with the extension lead, there are 4 sockets, so therefore all 4 sockets need testing. So we will just repeat that process over 4 times to ensure that that appliance is in order, and then that is the test complete. We would apply our label in the most appropriate part where it's visible. And what we would first do is make sure that there's no dust or grease or anything where we're going to apply the label, so the label actually sticks. So we're now going to look at testing this 110 extension lead. And with flexible cable, we need to work out from the length and the CSA, the cross-sectional area of cable, the resistance level. Now, there is a mathematical equation with that. However, I like to keep things simple. And a quick Google of a pat testing earth limit calculator will bring back a number of websites where you can just put in the details just to make your life easier. So I've already pre-measured this cable and I know it's 12 meters long and the cross section is 2.5. So that's telling me that the earth pass mark should be no more than 0.2 for it to achieve a pass. So that's what I'm going to be working towards. So with cable, you need to be able to take it to its full length and make sure that it's in its order. Again, we're going to do a visual inspection, making sure that we've got no cuts or tears, exposed metalwork coming through. And I'm happy with that. So we're going to sort of put the cable out, and then we need to make use of 2 adapters in order to conduct the test. So they go in there as such. The plug part goes into the pat testing machine, and the IEC part goes into obviously the IEC part of the pat testing machine, and then we're selecting a class 1 110 volt test. So we go through the actual test. That's all showing okay. The earth reading's fine. The insulation's fine. So as with anything else, we then fill in the details onto our pat testing machine, paper or iPad, ready to submit through to the office later. And again, we'll find a nice clean spot to attach our label. And that is the test complete.
When we get a booking with a job, the first thing that we'll do is we'll contact you to make sure that you can fit it into the schedule on your calendar. Once we confirm the job, we will pop the calendar entry on, and every single detail that you will need will be on that calendar entry. The site name, the site address, who the client is, how many approximate items there are, the opening times and your site contact. It is extremely important to check that calendar every single day, as it is a live tracker for any new information that is being added to each job. So therefore, please ensure that you check that calendar every single day.
When you arrive on site, make sure that you are wearing your appropriate JR Pat Testing t-shirt, smart black trousers and appropriate footwear for whatever site you're attending. Also make sure you have your ID badge. These will be supplied before you attend a site.